that we went over yesterday in class? Okay, so like I said, you can either drop them off with me tomorrow when I'm on campus, or Thursday if you are in the classroom, you can leave them on the desk. Otherwise, we can get them from you next Monday. Um, but we need to have those done so we can get them in the grade book and get everybody caught up. So right now, we're going to start Unit 2. In Unit 2 is about the geometry that we're going to use to form the basis of the trig that we're going to be doing in just a little bit. The geometry that we're going to do, many of the things we're going to look at are common sense, but we have to put them in words just because they're so obvious in some cases that you wouldn't think of them if it wasn't specifically stated. Some of the things that we look at might be I don't want a full line, I just want a line segment. On a line segment, if I have it divided into two pieces, if I know this length here is 6 inches, and I know this length up here is 9 inches, the length of the whole thing is 15 inches. It's just the sum of the parts. But that's only true if it is a line segment, if it's truly a line, as long as it's straight. In other words, these 3 points are what we refer to as collinear. In other words, they do line up perfectly. We can draw that line through them. If they are not collinear, so if we have 3, that's called non-collinear points. If I connect them, I'll label my points A, B, and C. If the distance from A to B is 8 inches, and the distance from B to C is 7 inches, the distance from A to C is not 15 inches. But we do know that it is no more than the sum of the other two, 8 inches plus 7 inches. So that this cannot be any more than 15 inches. It has to be less than 15 inches because that would be the distance if these points were in a straight line. It would be the sum of those two distances. So a lot of what we do in geometry is not necessarily knowing exactly what a number is. It is knowing what range it has to be in. I want to review some things from last semester with you. I'm going to have you look at this problem here for just a minute. I'm going to tell you that this here is 48 degrees, and this angle up here is 57 degrees. Find those 12 angles. I'll give you a couple minutes to work on them, and I'll be right back. these angles, there's two very simple rules that apply here. One is when we have parallel lines, and these two lines here are parallel, cut by a transversal, all the angles formed are either the same angle or they're supplements, unless there's something else interfering with them. So let's look at this transversal here. This 48-degree angle has to be the same as this one here. This has to be 48 degrees, which has to be the same as this one over here, 48 degrees. Another rule is something called vertical angles. When two lines intersect, the angles that are on the opposite sides of those intersecting lines are vertical. They have to be the same. The yellow and the pink lines intersect here. Those two angles are on opposite sides. We know that this angle is also 48 degrees because it's vertical to that first 48-degree angle. Next, we know that this angle here is 132 degrees because this is a straight line here. Those two angles add up to a line, meaning they're supplementary. So we subtract from 180, the 48 from 180 to get 132 left. That angle has to be 132. This angle down here also has to be 132 degrees because, again, it's vertical with that original angle number 1. From there, we have to jump over to this angle. And so we'll use this transversal now. That 57-degree angle has to be the same as this one here, because they're on the same transversal. This has to be 57 degrees. The 12 up here has to, again, be supplementary to that, so 180 minus 57, which will give us 123 degrees, which means this is 123 degrees. Now we're left with angles 9 and 6. Angle 5 over here actually also has to be 57, because it's vertical with this one, from the same two intersecting lines. Find angles 9 and 6. We know that this is a straight line. When we talked about supplementary angles before, we only talked about two angles that added up to 180 degrees. But we can have sets of angles that are supplementary. Here we have 3 of them. Those 3 angles add up to 180 degrees. So I take 180 and I can subtract 57. That'd be 123. And then also subtract the 48. Leaves me with 75 degrees. This angle here, angle 6, has to be 75 degrees. And of course, angle 9 would also then have to be 75 degrees. Now, there was another way we could have found angle 9. One of the rules is that when we have a triangle, and this, of course, here is a triangle, that the 3 angles of the triangle must add up to 180 degrees. If I were to take that whole triangle and start with 180 degrees, I would subtract the 57 degrees here and the 48 degrees here. Notice that's the exact same calculation we just did for the 3 angles that added up to the supplement, or the 180 degrees. So there's a lot of things in our geometry that are linked together. That idea that a triangle has to have 3 angles that add up to 180 degrees is something that plays over and over again as we look at finding missing pieces of triangles. So we are familiar with those structures, the angles, the triangles. We went over last semester how everything in geometry starts from a point and is created by moving that point. And we dragged the point to create a line segment, where the length of that line segment was equal to the distance that we moved the point. Excuse me. The cold weather, I got a little bit of a cold coming on. So anyway, we have that. We can take a point and we can move it in a single direction and keep going on forever, that's called a ray. A ray has two properties. One property is its starting point. Starts at that point. We know where that is on this one. And then it has a direction. The direction is defined in terms of the old navigational directions. Now, they have redone the way they do navigational directions, but historically, the way it was done was east, if you're looking at the map, was 0 degrees. North was 90 degrees. Then we proceeded around counterclockwise. So west would be 180, south would be 270, and then 360 would be back to east again. So we set up that grid with the center of the grid at that starting point of our ray, and then the direction of our ray was found off of that grid. Let's just say that that is 22 degrees. Now, if I take a second ray off the same starting point, that same starting point, and I'm going to go in a different direction, like that. So that ray has the same starting point, but a different direction. And let's say that the direction of that ray, let's call that 53 degrees. Those two rays with the same starting point create what we call an angle. And the size of the angle is the difference in direction. So the difference between those two directions there, between 53 and 22, 31 degrees. So that angle is said to be 31 degrees because there's 31 degrees difference in the direction of the rays that make up its sides. Now, an angle can be named in several ways. I could just put a number there and call that angle 1 or angle 2 or angle 3. I can name the vertex. That'd be angle P because the vertex is at P, or angle 1 because it's labeled angle 1. Or if there were several angles, let's say I have another ray coming off of that. This one might be labeled angle 2. But if I wanted to reference without the numbers, if I wanted to reference by points, so I have point U, point M, and point C, I could reference an angle by the points on its sides and its vertex. Angle UPM, that's saying it starts at point U, goes to point P, and then to point M. Notice the vertex is always going to be that middle point. Or I might have angle UPC, starts from point U, goes to point P, and then to C. Again, notice the vertex is the middle point again. So there are several different ways of referring to these angles. Depending on how obvious it is, how complex the drawing is, we have to go into more or less detail when naming it. That part there is just to make sure we understand our notation as we move forward, because the book and our assignments are going to refer to angles in several different ways. So the measurement of those angles. We said it's difference in direction. Well, that navigational system is not as common as it used to be. It used to be extremely common, but now not as commonly known as what it used to be. So we often look at it in terms of full turn. We're facing a direction and we turn all the way around to make a full turn. That's 360 degrees. One full turn. We start facing in a given direction and we turn so that we're facing in the exact opposite direction. That is 180 degrees. Or a half of a turn. What you think about it, 1/2 times 360 equals 180 degrees. Or if we're facing in a given direction and we turn, so we end up facing exactly to the right of where we were facing, that's 90 degrees. Again, you can think of that as a quarter turn, a fourth of a turn. So 1/4 times 360 is 90 degrees. But more importantly is the backwards calculation here. This is said to be 180 degrees. 180 degrees divided by 360 degrees. 360 degrees being a full turn is 1/2. That's saying we've made 1/2 of a full turn. 90 degrees over 360 would be 1/4. Again, saying that that is 1/4 of a full turn. We have an angle that is said to be 60 degrees. Put that as 60 degrees over 360. I reduce that, it becomes 1/6. That is saying that that is 1/6 of a full turn. The degrees that are the measurement of our angle are telling us what fraction of a full turn we have made. 40-degree angle is going to look something like that, but more importantly, we can look at this 40 degrees out of 360 and reduce that. That is 1/9 of a complete revolution, of a complete turn. So we have measured our angles. We're used to measuring them in degrees, and then we're going to keep measuring them in degrees for now. But we can get more precise than just a degree. Just like we had feet and inches, yards, feet, and inches even, you have larger units to smaller units and even smaller units. Angles can be broken up in the same way. 1 degree for an angle is 1/60th or 1/360th of a turn. Well, that can be broken down into minutes. 60 minutes. The abbreviation for minutes, this is where it gets a little bit confusing in construction. 1 degree equals 60 minutes. The abbreviation for minutes is that single quote, which is the same abbreviation we use for feet. Well, as we go smaller, 1 minute can be broken into 60 seconds. You might have guessed it, the abbreviation for seconds is a double quote, the same as used for inches. So we have to be a little bit careful determining when we look at these measurements to make sure we know whether it's minutes and seconds or if it's feet and inches. Now, typically an angle will have degrees on the front of it. So it might be like 18 degrees, 27 minutes, 30 seconds. The fact that it starts with the degrees here tells us that that's minutes and seconds, degrees, minutes, and seconds. Should be no confusion. The only time there'd be really any confusion is if it might be 45 minutes and 20 seconds. Looking at that, is that 45 feet and 20 inches? Well, it can't be, because we would never have 20 inches when we have feet as well. We would have broken that down, that we would have taken the 2 feet out, or 1 foot out of there and left it as 46 feet 8 inches. We would never have left it as 40 feet, 45 feet and 20 inches. So some of the things you can use as clues to tell you that is not feet and inches, that is minutes and seconds when you read that. So the only time it's really confusing if it's less than a degree and if the seconds are smaller than 12. Then it's hard, you can't just tell from the numbers. You have to use the context of where you're seeing that to figure out, is that feet or inches or minutes and seconds. The realistic side of this. In construction, very seldom will we ever measure anything that's smaller than a degree when we're cutting or building or any of those things. In cabinet making, you might get down into angles that are a quarter of a degree or 15 minutes just to make sure things are very precise. That's about as small as I've ever seen anything in wood manufacturing. In metal manufacturing, I know a couple places that go down to 5 minutes, which 5 minutes, 5 over 60 is 1/12 of a degree when doing their manufacturing. But where the degrees, minutes, and seconds will come in on the construction side is in surveying. In surveying, there is a ton of math involved in finding the distance between points, the direction from one point to another. Unfortunately, the degrees, minutes, and seconds work slightly different in surveying than what you would expect because we're not dealing with a flat surface, we're dealing with the surface of the globe or a sphere. So that we have to involve what's called spherical angle calculations. But you would work with degrees, minutes, and seconds when finding those angles in surveying. Many of you will never encounter that. You might work with a surveyor, but you'll never have to do the surveying or read necessarily those survey results on your own. But it is a possible branch, a possible portion of construction that you might find yourself into. I've had a couple of students through the years that were, one that went to work as a surveyor's assistant for Finley Engineering, and one that actually went on and became a certified surveyor for a company in the area. Good money, not a bad career. So let's take a look at our two ways of expressing angles that need to be measured in more detail than down to just a single degree. The way that we're probably most used to seeing them is in decimal degrees. We're going to abbreviate this DD for now, for decimal degrees. You might see an angle like 37.6428 degrees. That's decimal degrees. That's definitely measured down more precise than just a single degrees. And then as we just saw, we can have degrees, minutes, and seconds. And our abbreviation to signify this is DMS notation, or degrees, minutes, and seconds. And we might have an angle listed as 18 degrees, 27 minutes, and 53 seconds. So you can see it's almost like our yards, feet, and inches. We have 3 different units combined together to make those. Both of these forms are acceptable in different applications. The decimal degrees is often the most used in cabinetry because we don't need to go much more precise than a quarter of a degree. The degrees, minutes, and seconds is used in machining when working with metal and medical instruments and precision machining, basically, because they need to be a little bit more precise. The decimals would get very complex to get those fine of an angles. And it avoids round-off error. So the temptation here, I went to 4 digits, which when we're looking at degrees, minutes, and seconds, if we go to decimal degrees, I want you to keep that as your standard, is if you have to round it, always keep at least 4 decimal places in that angle before you round it off. Whereas in the degrees, minutes, and seconds, it's built in that we have to stay to those smaller units before it gets rounded. Typical, we might round to the 10th of a second. I always round to just the nearest whole second. To me, a 10th of a second is a little unrealistic. The most precise manufacturer I've been in the consulting work I've done, measured the nearest 5 minutes. I have never seen a manufacturer that's able to measure that produced to anything smaller than that. I've seen measurements smaller than that, but it involves lasers. Very precise, and it's tough to get the inconsistencies in the surface usually are greater than a few seconds when you go to measure an angle. So our next step is to look at converting between these. So I'm going to take something like, I'm going to take totally different angles in my examples here. I'll take 43.2174 degrees. And I'm going to convert it to degrees, minutes, and seconds. So this process is very similar to what we did when we took decimal feet and we converted to feet, inches, and sixteenths. So I have that decimal in my calculator, 43.2174. Convert it to DMS, I take the full degrees off. It's going to be 43 degrees. I take my decimal portion, the 0.2174, that is in degrees, is going to have to be converted to minutes. Well, 1 degree is 60 minutes. So I'm going to multiply that. I'm going to subtract off the 43. I'm going to multiply that decimal by 60 to get 13.044. That is now in minutes. If I take off the whole number there again, 13 minutes, and the 0.044 minutes has to now be converted into seconds. Oops, this should be a single quote, not a double. Doing that all morning for some reason. So 1 minute is 60 seconds. So up to the 0.004, I'm going to subtract off the 13 here to be left with the 0.044. Multiply by 60 to get seconds, 2.64. Oh, I said we could go to the nearest tenth of a second if we wanted to, but there's really no need to. I'm going to call that 3 seconds. Notice I left that 0 in there so that it takes up 2 digits. That is very common. Most of your digital readouts, even if you're entering degrees, minutes, and seconds on your calculator, will require that 0 in there to fill that place. Some calculators will put it in for you if you don't. Others, you have to put it in or the calculator gets confused. Anyway, we have done a conversion from decimal degrees into degrees, minutes, and seconds. We'll do another one here. 19 point, what did I use here? 7436 degrees. And again, we're going to go to degrees, minutes, and seconds. So I'm going to just take off the 19 right away. 19 degrees. Now I'm going to do the rest right in my calculator. I got 0.7436. That is the decimal degrees that are left over after I took off the 19 full degrees down here. I'm going to convert those 0.7436 degrees into minutes by multiplying by 60. That's 44.616, so that's 44 minutes. I'm going to remove the 44, subtract the 44, take my 0.616 minutes and convert it into seconds by once again multiplying by 60. Well, 36.96, I'm going to round that to 37 seconds. So that's converting, that is decimal degrees, into degrees, minutes, and seconds. Let's go the other direction. Let's take 37 degrees, 14 minutes, and 42 seconds and convert it into decimal degrees. And remember we said go to 4 decimal places when we go to decimal degrees. I have to work this process totally backwards. I start with the seconds, the 42, and I divide by 60 to get 0.7. Divide by 60, that is 0.7 minutes now. I bring down my other 14 minutes to go with that. I add my 14 minutes to that 0.7. Now I have to convert those minutes into degrees. I'm once again going to divide by 60. Gives me 0.245. Well, that is degrees. I bring down my 37 with that. That is 37.245 degrees. So it's just a matter of dividing, combining, and then dividing again to get to where we need to go. Let's do one more example of that. We have 19 degrees, 51 minutes, and 18 seconds. A little clearer. And once again, we want to convert that to decimal degrees. I'm going to do this in the calculator. Now I'm going to start with my seconds again, my 18 seconds, divided by 60 to get that 0.3 minutes. So now I'm going to add the minutes that were already there, the 51 minutes. So add 51, 51.3 minutes. I need to convert that into degrees so I can combine it with the 19. So again, I divide by 60 to get 0.855. I add that to the 19 degrees that were already there. I have 19.855 degrees. Somehow I came up with two examples that came out well to 3 decimal places. Most of the time they will not do that. Most of the time you will get a repeating decimal that will have to be reduced. The next step is to do operations with our angle measurements. I might have 42 degrees, 18 minutes, 47 seconds, plus 11 degrees, 48 minutes, 39 seconds. If I want to add these two angles, it is just like any other addition. I'll start at the right and I'll work my way back to the left. I combine 47 and 39 is 86 seconds. That's bigger than 60. We can get a full minute out of there. We can only get 1 minute out of that. That 1 minute would be 60 seconds. So we subtract, there's 26 seconds left over. So that 86 seconds was 1 minute, 26 seconds. So we kept the 26 seconds. We're going to carry the 1 minute. So now we've got 1 and 18 makes 19. 19 and 48 makes 67 minutes. Well, again, we have an issue here that 67 minutes is bigger than a degree. 1 degree would be 60 minutes. So I take that 60 minutes out of there. That would leave me with 7 minutes. I'll make it 0, 7. So I keep that 7 minutes and I carry that 1 degree. 42 and 1 is 43. 43 plus 11 is 54 degrees. So we have 54 degrees, 7 minutes, 26 seconds is the sum of those two angles when we add them together. I might have 19 degrees, 52 minutes, 29 seconds, plus 23 degrees, 31 minutes, 44 seconds. Again, when I go to add these, I start on the right. 29 and 44 makes 73 seconds. Again, that is bigger than a minute. So I take out my 1 minute. That would be 60 seconds I just removed, leaves me with 13 seconds. So I'll keep my 13 seconds and carry my 1 minute. So I've got 1 and 52, that makes 53, plus the 31 makes 84 minutes. That's bigger than 60, so that's bigger than a degree. We can get 1 degree out of that, and we subtract the 60 minutes in that 1 degree, leaves us with 84 minus 60 is 24 minutes. We carry the 1 degree. And of course, now we have 1 plus 19 is 20, plus 23 is 43 degrees. 43 degrees, 24 minutes, 13 seconds. All right, try one in your notes. 22 degrees, 17 minutes, 58 seconds, plus 17 degrees, 48 minutes, and 19 seconds. I'll give you a minute to add those, and then we'll go over them. So if we start on the right, working our way back to the left here again, we'll start with the seconds. 58 and 19 make 77 seconds. Well, that is bigger than a minute, so I'm going to take out 1 minute. Takes out 60 seconds, so that's going to leave me with 17 seconds. I carry my 1 minute. 1 and 17 is 18, plus 48 is 66 minutes. That is going to have 1 degree in it. Subtract my 60 minutes for that 1 degree. Gives me 6 minutes left. I put a 0 with that. Carry my 1 degree. 1 and 22 is 23, plus 17 is 40 degrees. That's 40 degrees, 6 minutes, 17 seconds. Let's look at subtraction. Subtraction, very similar. We just have to do their borrowing. We might have 28 degrees, 14 minutes, 32 seconds, minus 11 degrees, 51 minutes, 43 seconds. So when I go to subtract here, again, I start on the right and work my way backwards to the left. 32 minus 43 cannot be done. That'd be a negative number, and I don't want negatives within this. So I have to borrow from my minutes. My 14 minutes becomes 13 minutes. That 1 minute that I borrowed is 60 seconds. 32 plus 60 is 92 seconds. Now 92 minus 43 is 49 seconds. Now I move over to the minutes. 13 minus 51 can't be done, so I have to borrow from the degrees. This will become 27 degrees. Again, what I borrowed, 1 degree, is 60 minutes. So 13 plus 60 is 73 minutes. Now I can subtract. 73 minus 51 is 22 minutes. Excuse me, now I can move over to the degrees. 27 degrees minus 11 degrees is 16 degrees. Giving me 16 degrees, 22 minutes, 49 seconds. Let's do one more example of that here. 39 degrees, 28 minutes, 13 seconds, minus 22 degrees, 43 minutes, 51 seconds. Again, we start on the right and we work our way backwards to the left. However, we cannot do 13 seconds minus 51 seconds. Again, that would be negative. So we're going to borrow. We borrow from the 28, that'll be 27 minutes. What we borrowed that 1 minute is 60 seconds, so 13 plus 60, 73 seconds. Now we have 73 minus 51 is 22 seconds. And we can move over to the minutes. 27 minus 43 cannot be done. So once again, we're going to look at borrowing. We'll borrow from the 39. That becomes 38 degrees. What we borrowed again was 1 degree. That is 60 minutes. 27 plus 60 is 87 minutes. Now I subtract 87 minus 43 is 44 minutes. And 38 minus 22 is 16 degrees. So it's 16 degrees, 44 minutes, 22 seconds. We're going to try one in your notes. 41 degrees, 32 minutes, 25 seconds, minus 18 degrees, 41 minutes, 58 seconds. I'll give you a minute or so to work on that, and then we'll go over it. So we start on the right, work our way back to the left. We cannot do 25 minus 58, so we're going to borrow from the 32. That'll become 31 minutes. So that adds 60 seconds here to make that 85 seconds. 85 minus 58 is 27 seconds. We come over here, 31 minus 41 cannot be done, so we're going to borrow here from the 41 degrees to make that 40 degrees. That adds 60 minutes to our 31 minutes to make it 91 minutes. 91 minus 41 is 50 minutes. Then 48 minus 18 is 22 degrees. So we have 22 degrees, 50 minutes, 27 seconds. Our next step is to look at multiplying angles. So if I have 14 degrees, 28 minutes, 49 seconds, times 4. Let's take a look at what we get. Well, again, we work right to left. We start at the end and work our way backwards. 4 times 49 is 196 seconds. That is bigger than a minute. In fact, it's bigger than 2 minutes. 1 minute is 60 seconds. 2 would be 120. 3 would be 180. So that's actually 3 minutes. We can take out 3 minutes from that. That removes 180 seconds, leaving us with 16 seconds. Now we carry that 3 minutes up here, and we'll multiply. 4 times 28 is 112 minutes, plus the 3 that we borrowed is 115 minutes. That again is bigger than a degree. There's 60 degrees. or 60 minutes in 1 degree. It's not bigger than 2. It would take 120 minutes to make 2 degrees. That's just going to be 1 degree. We'll subtract that 60 minutes from there. Give us 55 minutes left over. And we carry our 1 degree. Finally, we have 4 times 14 degrees is 56 degrees. Plus the 1 that we carried makes 57 degrees. 57 degrees, 55 minutes, 17 seconds. Let's do another example of that. Let's take 21 degrees, 38 minutes, 19 seconds, and let's multiply by 5. So we have 5 times 19 is 95 seconds. That is bigger than a minute. Only bigger than 1 minute. 60 seconds would be 1 minute. It would take 120 to be 2, so it's not 2. We subtract out the 60 seconds for that 1 minute, leaving us with 35 seconds here. We carry our 1 minute. 5 times 38, which is, was that 390, I believe? Or sorry, 190. That's plus the 1 we carried is 191 minutes. Now that's bigger than a degree. 60 minutes would be a degree. Bigger than 2. 120 minutes would be 2 degrees. In fact, 180 minutes would be 3 degrees. So we can get 3 degrees out of that. We've used up 180 minutes. So we subtract 191 minus 180, that's 11 minutes. Carry our 3 degrees. Now I've got 5 times 21 degrees is 105 degrees, plus the 3 that we carried, 108 degrees. It gets to be a little bit of a tedious process, but not so bad. I'm going to give you one here to try in your notes. 18 degrees, 45 minutes, 38 seconds. Multiplied by 3. Give you a minute, then we'll go over that. We'll start on the right side and work our way back to the left again. 3 times 38 is 114 seconds. Bigger than 1 minute, but not bigger than 2. 2 minutes would take 120. That's 1 minute. We subtract out those 60 seconds. We are left with 54 seconds there, and we'll carry our 1 minute. So now we have 3 times 45 is 135, plus the 1 we carried is 136 minutes. 60 would be 1 degree. 120 would be 2 degrees. So we can get 2 degrees out of that. We'll subtract out that 120 minutes, leaving us with 16 minutes. We carry our 2 degrees. 3 times 18 is 54 degrees, plus the 2 that we carried, 56 degrees. Got 56 degrees, 16 minutes, 54 seconds. Our next piece is to look at division. So we might have 47 degrees, 31 minutes, and 28 seconds divided by 4. We're cutting that angle into 4 equal pieces. So division, remember, is the one operation that goes left to right because we want to subtract out the larger chunks first. So 4 goes into 47 11 times. We're labeled at 11 degrees. 11 degrees times 4 is 44 degrees. Now we can subtract. 47 minus 44 is 3 degrees. Before I can bring down my 31 minutes, I have to convert those degrees into minutes. 3 degrees, 3 times 60 is 180 minutes. Now I can bring down the 31 degrees, giving me a total of 31 minutes to give me a total of 211 minutes that now has to be divided. 4 goes into 211 52 times. 52 times 4 is 208 minutes. I subtract there, I have 3 minutes left over. Once again, before I can bring down my seconds, I have to convert that 3 minutes into seconds. 3 times 60 would be 180 seconds. Now I can bring down my 28 seconds to get a total of 208 seconds. 208 divided by 4 is 52 seconds. 52 times 4 is exactly 208, so there's nothing left over. So that 47 degrees, 31 minutes, 28 seconds, divided into 4 equal pieces, is 11 degrees, 52 minutes, 52 seconds. Let's try, I'm going to do another example, I'll do it down here. "37 degrees, 48 minutes, 35 seconds, divided into 5 equal pieces. So 5 goes into 37 7 times. Call that 7 degrees. 7 degrees times 5 is 35 degrees. We subtract 37 minus 35, we have 2 degrees left over. Now before I can bring down the 48 minutes, I turn that 2 degrees into minutes. It's 120 minutes. Now I can bring down the 48 minutes with the 120 minutes to get 168 minutes. 168 divided by 5 is 33, I believe. 33 minutes. 33 times 5 is 165 minutes. I subtract 168 minus 165. There's 3 minutes left over. Once again, before I can bring down the 35 seconds, I turn those 3 minutes into seconds. It'll be 180. 35 plus 180 gives us 215 seconds. 215 divided by 5 is 43, exactly 43 seconds. So 7 minutes, or 7 degrees, 33 minutes, 43 seconds. If you try one in your notes, 15 degrees, 29 minutes, 42 seconds, divided into 3 equal pieces. I'll give you a minute, then we'll go over that one. Let's take a peek here. We start 3 goes into 50. That's 16 times. 16 degrees times 3 would be 48 degrees. That's going to be 50 minus 48 is 2 degrees left over. We turn those 2 degrees into minutes. 2 times 60 is 120 minutes. We bring down the 29 minutes we had. That's now 149 minutes. 149 divided by 3 is 49 minutes. 49 minutes times 3 is 147 minutes. Subtract, that leaves us with 2 minutes. We turn those 2 minutes into 120 seconds. Then we can bring down the 42 seconds to get 162 seconds. 162 divided by 3 is 54. Exactly. So that's 16 minutes, 49, or 16 degrees, 49 minutes, 54 seconds. Recall that a supplements are angles that add up to 180. So if I give you a 47 degree angle and ask you to find the supplement, well, it would be 180 minus 47, which would give us 133 degrees. But if I give you an angle that is 68 degrees, 27 minutes, 43 seconds, and I ask you to find the supplement, the process becomes a little bit more difficult. It's going to be 180 degrees minus that, but I have to fill in 180 degrees, 0 minutes, 0 seconds. Then subtract the 68 degrees, 27 minutes, 43 seconds. When I go to subtract here, obviously I'm going to have to borrow because I cannot do 0 minus 43, but there's nothing here to borrow from, which means I have to go all the way down to the 180 to borrow. So this will become 179 degrees, which would make this 60 seconds. But I don't need there. I need to get all the way down here, so I have to borrow again. Borrow from that 60 to make it 59 minutes. This is now 60 seconds. Now I can subtract. 60 minus 43 is 17 seconds. 59 minus 27 is 32 minutes. 179 minus 68 is 111 degrees. So the supplement of that angle is 111 degrees, 32 minutes, 17 seconds. I might ask you to find the complement of 39 degrees, 49 minutes, 23 seconds. Same concept. Remember, complement adds up to 90 degrees. We'll start out with 90 degrees, but I'll put in my 0 minutes and 0 seconds. I'm going to subtract my 39 degrees, 49 minutes, and 23 seconds. Once again, I'm going to have to borrow. So I need to borrow here. 0 minus 23 can't be done, but there's nothing here to borrow from, so I just keep going over. I borrow from the 90, make that 89 degrees. That makes this 60 minutes. Borrow from that 60 now to make that 59 minutes, make this 60 seconds. Now I can subtract. 60 minus 23 is 37 seconds. 59 minus 49 is 10 minutes. And 89 minus 39 is 50 degrees. So I get a complement of 50 degrees, 10 minutes, 37 seconds. Well, I think with those 2 quizzes, or 3 quizzes for some of you, and that test still lingering out there, I don't think I want to cover any more new material today because I don't want to push you even further behind. For right now, I'm going to have you look at, in the big book, page 523 to 524. This will be in the unit exercises. I should use problems 3, 4, and 5 there. It's just going over some of the basic rules for geometry. Page 532 through 533. This is exercise 20-1. 7 through 61, the odds. Page 536 through 537. Exercise 20-2A. 7 through 41, the odds. And finally, page 539 through 540, exercise, you guessed it, 20-2B, 7 through 39, the odds. I think that'll be enough for you for today. I'll let you have, we skipped our break, so technically we only have about 30 minutes left here anyway. I'll let you have that last 30 minutes to get started on your homework. I'll be on the network here for a while if you have any questions, so I can